First of all, thanks very much indeed for joining us. Really appreciate it. Thank you.
You're welcome. Thank you for the invitation.
So, what is Moire Quantum Matter?
So Moire Quantum Matter, so it has two, there is matter, so it's materials. There is quantum, it's, materials where quantum mechanics plays a very important role in explaining the physics of these objects. And then there is moire. Moire is a word that comes from textiles, and it means when you superimpose two periodic structures, then there is this super periodic modulation which appears on a much longer scale, and that is where the moire aspect comes from. So it has to do with materials where there is a super periodic structure, much larger than the atomic scale that makes these two materials that we're putting on top of each other. And it describes a large class of materials. The first investigation was just to put graphene on top of graphene with a twist angle between the two. You put two periodic structures on top of each other, and then you form this big superperiodic structure. And the electronic properties of materials change, and they can change very dramatically.
And why is it magical?
The word magic for the magic of Moire Quantum Matter comes from the fact that the first and most dramatic manifestation of this Moire Quantum Matter happened in what we call magic angle graphene. So this is two graphene sheets placed on top of each other, as I just mentioned, and they're twisted to a particular value which was coined by my theory colleagues, the magic angle. And it's magic because something very unusual and unexpected happens in the electronic properties of these materials, and they use the word magic to give it extra boost or something. But it is actually quite remarkable, almost magical, the thing that happens, how the electronic properties of these materials transform, and they do something that is almost unprecedented, in the history of material science. That's why it's a little bit magical.
Sounds pretty magical.
Yeah.
And what are some of the applications of this research?
So we have been working on this Moire Quantum Matter, me and many other groups, for about 5 years. It's a bit early to speak about applications. For now, we're mostly having fun with the fundamental physics, but we have, what we're finding with this Moire Quantum Matter is that we can realize pretty much all of the phases of materials, of quantum materials, superconductors, correlated insulators, topological materials, ferromagnets, ferroelectrics, all the phases of condensed matter physics, we can realize them in a very simple platform. And moreover, these are all electrically tunable. So we have a much higher degree of control over the electronic properties of quantum materials than we had before. So that may enable many new types of applications in the future if we're able to control these things and grow them at scale, these materials, etc. Some of them are related to new types of computation, whether it is classical or quantum computation. Some of them involve special types of neuromorphic computing using new types of ferroelectric materials. We can also realize special topological applications, superconducting detectors. There are all kinds of quantum applications that we could realize if we're able to scale these technologies.
What do you see, looking further ahead, what do you see as coming next for research into quantum matter?
So there are plenty of avenues of research for Moire Quantum Matter. One of them, for example, is the fact that right now we have been putting on top of each other only a couple of materials, and exploring their properties as Moire Quantum Matter, but there are hundreds of materials that we could put on top of each other. So there is still a vast space of materials to investigate and realize new types of Moire Quantum Matter.
Final question, a bit of a personal question. My final question is, what do you put your success down to? You've won a whole list of awards. I'm tempted to say it's magic, but clearly not. So what do you put your success down to?
Well, I think by far the most important thing is to have a great group of people, of young students and postdocs that make this happen. That's by far the most important thing. So if you want, the magic might be in selecting good people. And then I also think that an important component is to take risks, to be an adventurous person. Many of the discoveries that we have made in my group, it wasn't obvious at all that we were going to land them. It took lots of risks exploring uncharted territory and doing things, even with hiring people that were maybe a little bit unusual, with an unusual background, which were able to contribute new things which were different from what we had in my group. So yeah, take risks, select good people, and of course work hard.
Well, thank you very much indeed for joining us. Really
You're
interesting.
welcome. Thank you for the invitation.